Science is supposed to be exact, definitive, rational. Take this coin, for example. If I flip it, will it be heads or tails? Well, if we knew every factor, such as the air current in the room, the force I put on the coin, what face it started on, yada yada yada, then we could accurately measure exactly what face it will be on. For example, heads. But this sort of exactness is getting more and more false as our understanding of the world gets better and, well, weirder. It lies in quantum physics and is contingent on the wave-particle duality of electrons and other quantum particles. Scientists had the idea that quantum particles were simply dots, individual particles whose positions could be determined, but a revolutionary experiment in the 1920s would disprove this belief. The way it works is this. Imagine this is an electron. I fire it into this dual pathway and it has to go through one or the other and then it hits the back wall. But it isn't actually that simple. See, this experiment proved upon proper analysis that particles also carry the properties of waves, thanks to this picture. When a group of electrons from this experiment formed against the back wall, they presented this, the same pattern formed by water when you conduct this experiment with it, and anything else that is a wave. This means that electrons have to be waves, and that you don't really have just this single particle, but instead an array of possibilities, like, say, this water formation. This water formation isn't just one electron, but instead every option for where the electron could be. Once we fire it, it moves forward towards the two pathways, and then it passes through both pathways at the same time, still acting as just the idea of an electron. It is not until it makes contact with the back wall that the mere idea becomes a definitive electron. This notion for a long time was just a controversial theory. Its idea that we can't know where electrons are until they are observed decries logic, and was labeled by its creator, Niels Bohr, the Copenhagen Interpretation of quantum mechanics. In fact, it was so heretic that even Albert Einstein refused to believe it was true. And he was right to be skeptical. This theory breaks physics as we know it. It leads to ultra-powerful supercomputing, teleportation, and even infinite multiverse theory. But, in this case, physics had to be broken.